In this video, you'll learn more about how you can work with CAN bus and LIN bus data through our free and open source Python API. In particular, we'll outline the key features of the API and example use cases. First, let's briefly recap what CAN bus data is. The Controller Area Network, aka CAN bus, is used in most automotives today, as well as maritime vessels and machines. To record CAN data, you can use a CAN bus data logger. For example, the CAN Edge 1 lets you record raw CAN data to an SD card. Further, with the CAN Edge 2, your data can be auto-pushed via Wi-Fi to your own server. The devices record CAN frames, which need to be decoded to physical values for analysis, typically via a DBC file. Once the CAN bus data is decoded, you can, for example, perform graphical visualization or statistical analysis using the data. For some use cases, you may prefer to work with your data in a GUI software tool. For this purpose, you can transform the CAN Edge log files into other formats using our MF4 converters. For example, if you wish to load the data in vector tools, or you can use the free Asam MDF GUI to review raw data, DBC decode it, and create graphical plots. While GUI tools are great for small-scale and ad hoc data analysis, use cases exist where they become impractical. For example, if you record everything from a vehicle without using filters or prescalers, you may be looking at more than 1 gigabyte per day. If you wish to analyze 3 months of data for 10 vehicles, that's almost 1 terabyte, which is not suited for GUI processing. Another example is when you are performing the same processing steps many times. For example, when you're extracting a specific report or result from a GUI tool. Here, you'll typically benefit from automating the process via scripts. You may also sometimes need to perform data transformation, cleaning, or pre-processing to enable advanced analysis, in which case scripting is often required. The same goes if you need to integrate your data with a custom system or database. Finally, if you need to extract results from your CAN data in near real-time, you cannot rely on manual processes or GUIs. In particular, if your use case needs to scale. This is where our Python API comes in. The API provides the basic functionality you need to quickly process your CAN and LIN bus data. The Python API is comprised of sub-modules, each of which provide core functionality. Let's quickly review the key features. First, the API lets you list log files between a start and stop time, making it easy to identify relevant log files from either your local disk or your S3 server. Second, you can easily load MF4 log files with raw CAN or LIN data into Pandas data frames or Python iterators for further processing. Further, the API lets you load DBC files and decode raw CAN or LIN data to physical values. The output can, for example, be a Pandas data frame, which provides a popular and standardized interface. The Python API modules are 100% free and open source with support for both Windows and Linux. We also provide multiple simple-to-use code snippets and classes which enable you to quickly get started. The Python API can be extremely useful to many practical use cases. Let's briefly look at some of the most important ones. First of all, one popular application of the Python API is to enable integrations of your CAN data into databases, such as InfluxDB. We provide plug-and-play scripts for this purpose, making it easy to, for example, visualize your data in Grafana telematics dashboards. The same script can be used with minor modification to enable integration of your data into other custom databases, systems, or even other log file formats. Another common use case is handling of transport protocol decoding. In both J1939, NMEA 2000, and UDS applications, CAN bus signals are sometimes split across multiple individual CAN bus frames. To decode this data, the individual frames need to be correctly combined into a single CAN frame with a payload length exceeding 8 data bytes. This is beyond the scope of many GUI software tools, but as part of the Python API, we provide basic classes and examples to enable the decoding of such data. When analyzing CAN bus data, you may need to perform statistical analysis, for example, to produce power consumption profiles. optimize cost, compute water depth, etc. Here, the Pandas interface offered by the API makes it very easy to leverage the wide array of existing Python packages and tools for statistical analysis. In particular, this becomes relevant if you need to use the data as part of machine learning algorithms. Such use cases often involve terabytes of data, which can be handled efficiently through powerful Python tools like Dask. Increasingly, automotive OEMs and aftermarket users wish to establish predictive maintenance for assets deployed in the field. For example, you may want to monitor battery status of warehouse forklifts and identify potential issues before they result in costly breakdowns. For this purpose, the Python API can be used to, in example, evaluate CAN signals versus defined thresholds and automatically send alerts when limits are exceeded. For example, you could have a CANedge 2 upload data to your AWS S3 cloud server and use AWS Lambda functions to automatically evaluate log files immediately when they get uploaded. For many users, this type of practical predictive maintenance can be a game changer with minimal setup costs. Finally, you may simply want to automate mundane, repetitive tasks that you do again and again. Python scripts are perfect for quickly converting a manual task into an automated task, potentially saving your team hours or days of work. We recommend that you check out our online intro article. This contains several practical case studies from other users that deploy the Python API to achieve their goals. Further, the intro contains links for our API examples repository, where you'll find sample data and DBC files, which will allow you to try out the Python API in practice. To learn more, go to our website or contact us.